Hi everybody, this is Morgan here with Positive Approach to Math. We are moving on our last topic of functions. We're going to be talking about the continuity of graphs. This is our final lesson, lesson 7, in our Algebra 1 topic of functions. So please follow along, and you know the drill. If you need a blank copy of anything, you can check the details below, and that lesson will be there for you, as well as an answer key to the U-tries and a detailed video breaking down the U-tries. This is a super short lesson. There are 3 different types of functions we're going to talk about and their continuity. So once we get that, we will wrap up with our functions. So thank you for watching, and hopefully I can clarify some things. So for continuity in Algebra 1, there's basically 3 types of continuity that we're going to talk about. The first is discrete. And how I remember discrete is I tell my kids dots, ordered pairs. Discrete is basically a bunch of singular points that are not connected. So I think discrete dots. And so what we're doing here is we're looking at images of graphs. And if you ever see a graph that is a bunch of points just plotted, it is a discrete function, meaning individual points, and you cannot connect the points because a fraction would not, or whatever, does not exist. A good example of a function that's discrete is when you're talking about people, and say you're saying, okay, this is Morgan and this is her height. This is Michael and this is his height, and you're mapping them. You wouldn't connect their 2 dots because you can't have a fraction of a person, right? So anything that you can't represent as a fraction on your x-axis typically, and you can't connect those dots, so it's just individual points, that is discrete. It does not, something that I noticed my students were getting tripped up on is they were thinking it either had to be in a specific pattern, the dots, or it didn't have to be in a specific pattern. So some kids were thinking, no, that's not discrete because it's in a pattern, or no, that's not discrete because it's not in a pattern. And the answer is it doesn't necessarily have to be in a pattern or not a pattern. What makes it discrete is that it is a bunch of individual ordered pairs that are not connected. So whether it's in a pattern or whether it's not, it is discrete. Okay. Next is continuous. So continuous, I like to say, so it's the opposite of discrete. Instead of the points not being connected, the points are connected. Think of it as a single line or curve. I call this, take your pencil, start on the left, and if you can trace the function you have and never ever pick up your pencil till you get to the other side or till you get to the end of the graph, it is continuous. It's meaning that as I trace that line or curve, there is no gaps that exist, okay? So continuous means it's just one smooth line or one really crazy curve, but there's no gaps in my function, okay? So think of it as the opposite of discrete. Instead of being individual dots, it's everything's connected, okay? And then last but not least, we have neither. And this is like neither, but also a combination. So if you have some things on your graph that are points and then other things that are lines, like you have a combination, that would classify as neither. We don't say both, right? We're going to say neither discrete nor continuous. Or if you have multiple lines, but in order to trace them, you trace a little piece, and then you have to pick up your pencil, that would be neither, right? If I have to pick up my pencil to get through all of the chunks of the graph, and it's not individual points, it would be neither, okay? So it's a good way to think of it is it's not continuous everywhere. It might be continuous here, it might be continuous here, but it's not continuous in the middle. Or it might be discrete here, and it might be continuous here, but it's not all or nothing. So it kind of has that combination. So looking at our example, I just gave you basically one of each. So hopefully we can use our understanding and not just process of elimination of determining whether a function is discrete, continuous, or neither. So looking at the first one, if you look at that, that is a bunch of ordered pairs, and there's no particular pattern there. They're not forming a shape, but they are a bunch of individual dots, and they are not connected. So that would classify as discrete. Okay. We'll fix that to you a little bit. Okay? The next guy, so what I would say is, okay, we definitely see points connected. So discrete's out of the picture there. So now we're going to say, okay, well, is it continuous or is it neither? So I'm going to start on the left, and I'm going to trace it with my pencil. And hopefully you can answer to me, did I ever have to pick up that yellow to get to another part of the graph? And the answer is no, that yellow connects everywhere, right? That entire graph, when I traced it with my yellow highlighter, I never picked up my pencil till I got to the end of that arrow. So when I never pick up my pencil, it's one curve or line. That is continuous. And last but not least, looking at that third one, so this is where you kind of see that combination. So here you're thinking, okay, I never have to pick up my pencil for that curve. Great. But I didn't highlight that entire graph. I only highlighted a piece of it. So now to get to the next piece, I have to pick up my pencil to get my highlighter. I can't do this and go right to that chunk, or else I have a bunch of stuff I highlighted that's not really a part of my graph, right? So I had to pick up my pencil, I traced, I got to the end, and now to get to the next part, I couldn't just drag it because that wasn't a part of my graph. I had to pick it up and trace the rest. So that would be neither. Neither discrete nor continuous. You could also see something with like dots in the mix, right? If there was little dots, that would still be neither, okay? Like I said, very, very short. So we saved the shortest for last. Some summary and helpful hints. We have that discrete is single points, dots, right? Real life example, here we go. Purchasing an item at a store. So if you're talking about items that you're purchasing one coffee cup, I don't know, you're purchasing one ring pop, right? I could not connect those, right? I cannot say I'm purchasing 1.5 of something. They're all singular items, right? And so that would be a discrete function. A continuous is when you can trace your pencil, never have to pick up your pencil. An example of that is the cost of gas as you fill your car up. So thinking about the cost, right, it's not just charging you whole dollars. You can pay $24.56. You can pay, right? So it's a continuous function. Also, I think about produce. When you weigh your produce, your bananas at the grocery store, for example, they don't say, oh, you can only purchase whole pounds of bananas. So you can buy 1 pound or you can buy 2 pounds, but you can't buy 1.5. They don't say that. They measure 1.55 pounds. So you can kind of connect the dots. They then alter the price based off that 1.55, right? And then last but not least, neither. Some points are connected, some points are not. You might have a combination of discrete and and continuous. You might have multiple continuous chunks, but not one big one. And so that would be neither. Okay? So I did leave you with, a little fun you try here. So the first 3 are you classifying, are they discrete, are they continuous, or are they neither? And the last is me asking you to draw a picture. And so remember, we are talking about functions. So don't just draw something wild. We want to make sure it's still a function so that it's still passing that vertical line test, okay? So have some fun with those 3. And as always, you know in the details below, there's an answer key for you to check your work. If you want to try it on your own and then check your work, there's also a video breaking down those problems. So we survived our functions topic. Awesome job. Thank you for following along if you've been with us from the start. And if you haven't and you've been popping in for the things you need, awesome. So keep up the great work. Please reach out if there's something I can do to help you. Leave it in the comments below. And I will be sure to alter that to make it a better experience for you. So like, comment, and subscribe. And thank you for taking the time. Hopefully that helped with your math journey. Good job, guys.